the executive outline in 15 minutes. This is human continuous operations for the next age. If human beings were meant to go into space, there must be resources in it sufficient to support populations. There are. The basic chemistry of matter states that all gases will compress. The physical properties of space allow us to use the releasing of any compressed gases as propulsion. After the inertia of acceleration ends, when we fire the rocket, we become motionless again relative to ourselves, but we are still going the speed of our thrust. At this point, we can fire the rocket again and add even more to our speed. In the frictionless, unimpeded inertial environment of space, we can continue to accumulate speed every time we fire our rocket. The same concept works on a microscale with ideas such as the solar sail and the microwave thruster. I call it the principle of cumulative acceleration. For example, if I have a rocket that will push my vehicle to 10 miles per hour, I can fire it again at the 0 point state when we are no longer pressed into our seats, and now the vehicle is going 20 miles per hour. I can continue the pulsed cumulative acceleration until I run out of fuel, with no upper limit in the environment of space. Venus has a thick CO2 atmosphere with a surface gravity of 0.904 Earth-G. At an altitude of 300 miles above its surface, it is 72 degrees Fahrenheit. Its CO2 atmosphere is dense and has a mass 93 times more than Earth's. We can construct a mechanical satellite that is essentially an oil rig platform with a drill that extends to the 72-degree range of the atmosphere, compresses and pumps the gas upwards into orbit, and fills barrels full of the compressed gas. It would be compact, full of thousands of tent poles for its pipeline. It will use an automated roughneck to extend the drill downward once in orbit. Each pole will have one-way valves that force the gas up into orbit, where it is compressed and bottled. Its compressors will be powered by solar panels. It can use the CO2 gas with auxiliary thrusters to maintain constant orbit. Its compact design will allow us to send it in one launch together with the remote staging and delivery vehicle. An unmanned drone or robot will be used to exchange full CO2 barrels with empty ones to be filled by the Oryx satellite. It will bring the full barrels to a staging area nearby and out of the way, where they will be bundled together for transport to Earth orbit by the freighter, a second RSDV. It is only necessary to design the thing with these sole functions in mind, and to power it with solar panels, and to propel it with the CO2 gases that it prepares and delivers. The fuel tanks will be designed for easy attachment to Oryx, staging together in bundles, and handling by the RSDV robot or pilot. They will be delivered to Earth, lunar, Martian, Venusian, or Jovian orbit by an RSDV freighter and sold to customers. The cost of a single launch to Venus, according to SpaceX's website, is roughly $350 million. The deployment of the Oryx system will be automated and overseen by humans. The RSDVs will be most viable as robots in the future, but should probably begin as piloted unmanned craft to expedite the mission and reduce startup costs. Once barrel bundles are delivered to Earth orbit, the fuel will be sold to any private, corporate, scientific, or government entity that wishes to maneuver in space rather than using the old ballistic way of throwing a rock and never seeing it again. They will now be able to drive around and come back home and refuel and go out again, indefinitely. Like oil, our product will also be usable as an assistive with all zero-gravity machines, such as central fugal gravity and electrical power generators. Its usefulness going forward is both uncounted and unquestioned. The Oryx system gives us the potential to exploit all gas worlds as fuel resources going forward. The moon is made of rock and has 1/6 the gravity of Earth. It has little or no atmosphere. Concrete is the most common construction material used by mankind. It is cheap, durable, and immense. It is formed by the mixing together of a cementing agent and rock aggregate with water and reinforcement, then shaped to specs. By shaping powdered cementing agent, liquid, and rebar to the moon, concrete holes can be built using the lunar rock. These can be of any imaginable shape and dimension. At 1/6 the gravity of Earth, they can be constructed piece by piece, launched into orbit with CO2 gas or catapults, and then assembled there to form the outer shell of massive vessels that we could never have dreamed of launching into space from the surface of the Earth. The concrete will be heat impact, and the first layer of radiation shielding. The concrete will be heat and impact resistant, and the first layer will be radiation shielding. The second layer on the internal side of the hole will be thick plastic flooring formed to fit. Plastic has been found to be a very good protective layer against cosmic radiation. Atop the plastic will be an electric heating element, and above that will be a thin layer of water like that found in a wetsuit. The final layer will be the human contact wall, and made from whatever suitable materials the customers will order. Whether it is wood or concrete or tile or stone or drywall is up to them. The electrical heating element will provide an extra layer of electromagnetic shielding against radiation, and also outlets for power across its motherboard. By designing the hole as a series of stackable interlocking concrete discs, costs of custom shapes are far reduced and productivity is increased with standard line molds. Any number of discs can be stacked and locked together by order. Engine rooms, cockpit, electrical generator rooms, bays, and other non-generics are also to be mass-produced. In this way, discs that need gravity assist spinning can spin, and those that do not will not. And all of the modular parts of each vessel will have a central cylinder for transportation between them. Concrete gives us the potential to exploit all rocky worlds as construction material going forward. Ganymede and Europa are water ice moons. Ganymede has a gravity of 0.146 g, and Europa has a gravity of 0.134 g. The Earth's moon has a gravity of 0.16 g for comparison. Water is the most necessary resource in any survival situation, followed by food, shelter, and fire. Water is vital to life and to industry. It is needed for construction of concrete. Ganymede and Europa are water ice moons of Jupiter with gravity less than lunar. This gravity force also gives us a very low requirement for escape velocity, making the extraction, shipment, and sales of ice and water from these moons far more cost-effective than delivery of water from Earth. CO2 fuel and/or catapults can be used to launch chunks of ice into orbit, where they can be gathered and transported by RSD freighters to lunar orbit for use in construction, drinking, and farming. These two water ice moons give us the resources required to support populations. QECOM, QECOM, or Quantum Entanglement Communications, is the means of communication actually discovered before radio that is instantaneous. No matter where one atom is in the universe, its entangled counterpart will instantly know whether it is displaying a 1 or a 0 by virtue of the various changes that can be done to the one immediately affect the other. It is not necessary to give the scientific details of quantum entanglement in this presentation or to go into its other ramifications for national security, banking, and computer engineering. The concept of the key is derived both from the acronym and the necessity of the containment of the specific particle. The containment is accomplished by means of electromagnetics, such as that done by a particle accelerator. However, other types of elements have been entangled in laboratories, such as diamonds, which could be incorporated into a command ring reader system rather than direct and constant electromagnetic containment. Both systems will require a lot of power to use. Whether it be a captain's ring or an entire room, the benefits of instantaneous communication anywhere in the universe cannot be ignored. While SETI may be obsolete, radio is not, and it also should be used for broadcasting short range, and as opposed to the singular two-way system promised by QECOM. Power. Electrical current is generated when a magnet pulls the outermost valence electrons of a copper atom along the line of a wire. Given the properties of space and its constant unimpeded inertia, it would seem that we could generate megawatts of electricity simply by setting a magnet spinning within a coil of copper wire. But it will not spin forever. The electrons, being of the same polarity, resist one another as they are pulled along, and our magnet would eventually stop. Some scientists have discovered superconductors that eliminate this electrical resistance and allow the free flow of current, but these only come about at extremely high or low temperatures and other highly sensitive conditions. The International Space Station operates at a paltry 128 kilowatts with its solar power. The largest dam on Earth, in contrast, produces 22,500 megawatts of electricity using the constant mechanical force of moving water to spin its magnets. In space, human beings can apply the mechanical force necessary to produce that kind of power. A labor class can operate dynamos enlarged and as many as those of the Three Gorges Dam in China, and produce the same amount of electrical power in our vessels. This labor class forms the foundational economy of every ship, station, and fort. The ability to produce electricity at any and every distance from stars is of supreme importance to space travel. You already know the myriads of things that electricity can do, and these are why it is vital to the expansion of life into the cosmos. A crew of 100 or 300 workers operating each dynamo in shifts will constantly produce megawatts for the vessel and form the basis of its economy. A vessel charged with expansion missions will carry a minimum flight, power, construction, engineering, and support crew. It will carry multiple ORC systems, RSDV freighters, some drones, powdered cement, ice water extraction machines, and catapults. Its focus is to deploy, repair, or operate ORC systems on gas worlds, set up concrete construction facilities on rocky moons, and retrieve water from ice moons. It is a frontier vessel designed for expansion of human infrastructure. Colonization ships will carry everything the lighter expansion ships carry, but also have gravity-assisted farm holds and settler decks. They will carry water, fuel, fish, sheep, seeds, plants, and people. Also, they will have catapults, life rafts, and other forms of emergency survival. Sheep offer meat and clothing and cordage for survival situations. All life multiplies exponentially. Lightest of the three, the science vessel carries drones, rovers, probes, instruments, and the resources and crew to support them. These are the first vessels to take advantage of orbital fuel supplies and reusability of one vehicle. With a single launch and deployment, ORC Systems becomes immediately profitable by sales of orbital fuel to the nations. Orbital fuel becomes the mechanical force of all zero-gravity machines. Operation of concrete production increases the sale and use of fuel tremendously and enjoys consistent growth as a result. Space travel becomes cheaper by volume. Labor classes are introduced for electrical power. Water is valuable. Everything is interdependent and expandable. Expansion of the human race into space means the creation of empires, the formation of new kingdoms, the development of revolutions, and of piracy. The primary resource of Earth becomes the export of ecosystems, of copper, metals, manufactured goods. Freedom should be granted to colonials to deter war. To control the ORC systems is dangerous. It must remain a neutral party, such as the Rothschild banks or the Rockefeller oil. In this way, all life can enjoy the ability to expand and to form its own kingdoms and countries, while these only retain profit and not territory, nor prejudice, nor imperial control. The end.